Hello and welcome to part 1 of rebuilding a 3.5 inch gauge Rob Roy. This is introduction and some of me building the boiler. As you can see here, I'm just going to mill out a flat section at the back of the boiler for where the firebox sits. I originally built this loco using a rather awful Chinese mill table on a Kerry Tools drill master. For those of you who don't know what that is, it's a pillar drill. It's an old one I acquired a fair old bit of time ago. I just recently acquired some new machinery. As you can see, the mill here is one of those bits of machinery, and the lathe that I've got also. It's a Warco VM180 lathe, 12-inch centre lathe. So I decided to remake a load of parts for it that were made rather badly on a pillar drill. Of course, milling on a pillar drill, I went through a few arbors and bits, so... You're going to have to excuse some of my rather bad video editing. I'm fairly new to Vegas Pro 14, so I'm just sort of testing it all out at the moment. So any hints, tips or pointers, throw them at me, I'll take them all constructively. Some of you will be wondering why I'm using steel for the boiler, and I guess I'm building more of a poor man's boiler, as the copper for it costs around £50 just for the tube alone. Thought it'd be interesting to give it a go with steel anyway, seeing as real life locos are built with steel boilers. Of course, rust is the first issue that comes to mind, and I'm sure there'll be some sort of rust treatment out there that I can put through the boiler to stop it from rusting. With the proper care, I'm sure it will last just as long as a copper boiler. Typically people use silver solder, or they braze these boilers together because they usually be copper. In this case it's going to be either MIG bronzed or brazed, maybe a little bit of silver solder, but I'm going to try to use the higher temperature things first and work our way down to the lower temperature. Being MIG bronzed obviously on the steel, it makes it a hell of a lot easier to attach the boiler together, because we can just simply pull the trigger and lay down a weld and the parts won't move drastically. And it doesn't require so much heat or effort. Now, one of the problems with MIG welding, which is why people don't use it on boilers, is down to porosity. It's where you get some rubbish in the weld and it creates a series of air bubbles, and sometimes you can't even see it. And if you did a weld test and you were to cut it in half, you'd get a big cavity, which would be no good for a boiler. I think in the case of this boiler, only working at 90 psi and tested to 180, the MIG bronze will be more than sufficient to hold the pressure of the boiler and hold it together quite nicely. Yeah, there's the MIG bronze joint. Ground it back a bit to make it a little less hefty and to check that it was all okay inside. As you can see, it's going to be a part copper and part steel boiler, more of a hybrid. This way the firebox and tubes will be copper, because I'd already built them before, and they will take the heat through the boiler a lot more efficiently than the steel will. The steel boiler tube, once it's up to heat, although it will take longer to get it to heat, it will keep the heat more stable, so it won't fluctuate with cold water being added so much. It will hold the temperature better. This is the smoke box that I made a little while ago. It's silver soldered together, made from steel instead of the brass tubing they tell you to use on the plans, and it's come out quite nicely. As you can see, the boiler cleaned up quite nicely on the edges once all the weld was smoothed down as well. In the next video I'll be making some sides for it to go between the back plate and the throat plate out of steel. This means they'll be able to be MIG bronzed together on the steel end to form quite a nice joint, and of course to the steel boiler. Thanks for watching, and subscribe to stay tuned for the next video in the series.